If you're looking for us, you can find us via Google by typing Art of Machine Design, and we're going to be right in the beginning. Sign up, and let's get started. Once you go through the sign up process, you're going to find yourself at the home screen. If you already know the analysis that you're looking for and the keywords because you're an expert, just type it right there. Euler buckling, Hertz contact. At a click of a button, it's intuitive. If you're exploring and you forgot exactly the keyword, you can explore by subject. So let's go to structures. Let's explore any of these subjects, either buckling, and it will show you the geometry, or let's just go to beam bending just to show you a simple cantilever beam, what the platform can do. The platform connects friends, but not friends like your Facebook friends, friends like in analysis. So you can go to a simply supported beam at a click of a button very quickly. Let's assume that the person coming in is either a student or someone who just needs a refresher on the limitations of the model. We have videos that include for introduction into the subject, the actual application, as well as the result in going over a sample. The books are also intended to show you either an intro level with the green, a practical level with this little blue icon, and a high theory deep equations with the dark purple. Now let's assume that we have a simple cantilever beam where 3 parameters can vary about 1%. This is called sensitivity analysis. So let's put 1 meter, and that parameter changes, let's say 1%, 2%. Check, let's put them all 1% just to show you something. Now I have a circular tube. That tube that I have physically is in the dimensions of inches. So let's just change the inches. The platform can take mixed units because we do all of our analysis in SI units. So it doesn't matter. It's a honey badger. Let's keep going. Now select material. You can change your materials. And let's do a force of a tip. And we're going to put 100 newtons. Let's assume that also changes by roughly, let's give it 1% as well. Run the analysis. And you get the numerical values for the system that we calculated, as well as the equations that were used to get those values. So you can go ahead and do a double check. Now we also include plots in some of the calculators, all available at an instant. And this is the unique thing for these calculators, sensitivity analysis. If I change 1% in the force, how does that impact my results? In the force, it's linear, 1 to 1. 1% change in force results in 1% change in the tip displacement, tip angle, and nominal stress. However, that's not always the case. Sometimes there's a different multiplication factor. We identify those factors because we're doing the equations and we're going through the system. Now let's show you a different calculator just to diversify. Let's put Hertz contact because it's fundamental for an engineer to understand Hertz contact. Sometimes in a book there's a typo or there's an assumption that is made. Now one of the things that we do as part of the universe plan is to document all of those equations, and if we find an error, we document it and they're available to you, or an assumption that is made that is not clear in a book. Let's preload a configuration. One of the things that is now going to be important is documentation, especially as you're doing medical products or for the aerospace industry or semiconductor industry. This is especially critical. What analysis did I do yesterday with what parameters to get me the results today? All of that becomes very simple because at a click of a button here, we request a PDF report and it will give you a summary of the analysis that was done, a schematic diagram, the QR code that will take you back to the platform, the details of who did it, and the inputs and the results that were calculated in the platform. Very quick, very succinct. Join us at Art of Machine Design. We are excited to have you as a member.